So recording has started. Yeah, go ahead. So this is the problem statement that we have. Basically, um, uh, idea is that we want to design a tiny URL shortener like Bitly, where you could pass in a long URL, and the expectation is that it should give us back the short URL. So this is like a one-liner statement I'm giving you, but I would want you to probe and ask me any relevant questions to complete your functional and non-functional requirements.
Yes.
Yeah. Ideally, yes. There will be limitations. Like we should have a character limit. But for now, for the simplicity of this problem, let's assume that there is theoretically no limit. It's just a text. So maybe we can assume that there's a 200, let's say 200 character limit, for example. Yeah. Mm-hmm. Mm-hmm. So that's a good question. So I would, instead of answering this directly, I would ask you, what, uh, wh- how does it matter if what implications do you see with respect to the size, the character length of the tiny URL? Uh, why do you think it matters? And if we make it more, let's say more number of characters, uh, how would it affect things? Or if we make it shorter, how will it affect things? Maybe if you can give me a brief answer, then I can. Yes. Mhm. Mhm. Okay, but one question before we proceed on that. So, you're correct on that part, that the more the number of characters in the URL hash, we will be able to support more number of URLs. But uh, you should also you should also mention that the domain of the characters also matter, like what all type of characters can come inside this. Can it be only alphabets, like lowercase alphabets or uppercase alphabets also, or it can be numerals also, or it can be UTF-8 character set. So you need to define well, like what's your character set. So if you just say that it's a small case alphabets, then it can be each letter can lead to 26 combinations, let's say. So depending upon if you are having a length of 5, you are able to support 26 raised to per 5, for example, unique URLs. But if you're using maybe base 62, which is your small alphabets plus capital alphabets plus numerals, um, 0 to 9, so then you can basically support technically 62 raised to per 5 URLs, right? So for now, let's say that length 5 is good enough, and we can go with the base 62 encoding, which basically means we can have the characters, we can have alphabets in A to Z, small case and uppercase, and the numerals. So yeah, let's go ahead with that. Right. That's correct. So let's the URLs can be utilized by anyone. Anyone visiting the short URL, they should be able to get the long URL back. For example, for now, let's say that there is no security constraints, nothing on those, and it's open to everyone. Mhm. Yes, let's say that that's a P2 requirement, not a P0 or P1 requirement. So analytics, we can. It's good to have. Let's for now say that these are going to be forever. We are not having a purging policy, but Optionally, we would want to support two things. One is users can actually mention the time to live. Let's say when would be the expiration date for these URLs that they are creating. So they can optionally provide that info, and going forward we can have a policy that a URL can only live, let's say, for 2 years, or maybe for 5 years at max, or maybe for an year. So we can configure that policy later on, but that's an optional thing. So once we are able to build the main flow, then we can get these discussions. If Yeah. Mhm. For now, let's keep it simple. So there are majorly, but before even going there, the two requirements I would want you to capture it very clearly. The first requirement is that the user can send us a long URL, and he should get back a short URL link. And the second use case is the user is sending us the short URL and we are redirecting them back to the long URL. So these are the two P0 requirements that we have. The rest of the requirements we have like all uh, P2s and P1s. So NFRs, this is good. This looks good to me. I think NFRs we have not defined yet. So maybe a couple of NFRs which are the important NFRs we can define. What according to you are the most important non-functional requirements that you can think of? The most critical ones, without which the system cannot function well. Mhm. So basically, that's that's a good highlight that you mentioned. But couple of things before that. So, what is the system that we are building? Is it a write heavy system or a read heavy system? What do you think? Hmm. Can you estimate the ratio of the read to write that is typically there in these kind of systems? Yeah. Yeah, generally in these kind of services, the read to write ratio you can think of like 100 is to 1, depending upon the use case. So if it's being used for social media kind of platforms, for example, let's say Elon Musk wanted to share something with his millions of users, or Trump or any celebrity wanted to share, so he would be just sharing the short URL link, right, in his tweet. So all his subscribers would go and click on that short URL to see, okay, what's it's all about. So the number of redirects would be like a lot more. So we can assume on a conservative level, like at least 100 is to 1, 10 is to 1, or maybe more than that. But yeah, that's a good but main thing I was looking at, that it's a read heavy system. That's a perfect point. So that's one. It's definitely a read heavy system. So and as you mentioned, we are not really making any acid compliant system over here. So a NoSQL database would make a perfect sense over here. The reason is that NoSQL provides us faster lookups, right? So we can have a NoSQL key value store. It can be in form of a, we can use any system like DynamoDB, Cassandra, or anything else for that matter. So a NoSQL key value store can work well in this case, and it's easy to scale as well. So if uh, yeah. Hmm. Yes. So API APIs can we keep it as a next section? These are the requirements that we are starting with. So API can go in the next section, not as part of the NFR. So in the NFR, one thing that I would have wanted to see from you is basically one requirement is that first of all, uh, we don't want any two long URLs to produce a same short URL. There should never be collisions. uh, so basically system should ensure that there should be no duplicates or no collisions for the short URL. So no two long URLs can have the same, can map to the same short URL. That is like one requirement. And the second requirement, I'll just give you a hint, maybe you can think about it. So yeah, you can write it. No two URLs can have the same short URL, yeah, or hash, whatever you. Okay, so the second thing I want to I want you to think in terms of the latency aspect. What do you think? Uh, your system is like read heavy, right? First of all, so what latency is going to matter more? Is the latency going to matter more for the generation part or for the redirection part? What is going to matter more here? Yeah. That's correct. So generally, as a rule of thumb, whenever we build any API for the stand, unless it's a bulk API, most of the API should be able to finish under 500 milliseconds, or to be precise, 100 milliseconds is like the usual, uh, uh, like P99 latency. So here we can assume that, let's say maybe half, under 100 milliseconds would be the P99 for the redirection part. So that is one goal that we can have. Yeah, so for writers, even if it takes a little bit, maybe more time than the reader's latency, it's completely okay, because the number of write operations, it's only going to be generated once and then going to be used multiple times, right? So 20 is to 1 or 100 is to 1, so it's fine. So maybe we can say under 1 second can be the right latency. Uh-huh. So consistency is like is like another topic in itself, and the context changes with respect to the problem statement to problem statement. But maybe let's talk about in terms of the gap theorem. So in terms of consistency or availability, what is going to matter here more? Okay, let me ask you in another way. Uh, consistency can have different meanings with respect to different problems. So, let me first define what the consistency here means. Okay, so that you are clear what is the consistency. Consistency here is not in terms of like two long URLs can have the same short URL. That's one of the requirements we have. But what does consistency actually mean? So in terms of the distributed systems, think of it like that let's say a user sitting in North America, he has generated a short URL mapping. So he has created a short URL for a given long URL. Now let's say Elon Musk, take the example of Elon Musk. He has generated this short URL link and he has shared this link on his social media handle. And now people all across the globe, they are trying to access this short URL and they are trying to get redirected to the original URL. Now, think of it in this way. Does it really matter that as soon as he shares the URL, let's say as soon as he generates the URL and shares it, let's say on the spot, is it required that people all over the globe, like each and everyone, maybe someone sitting in Australia, someone sitting in Antarctica, someone sitting in Africa, all of them should be able to instantly see the long URL? They should be instantly able to get redirect. What if people in some regions are able to get the redirects, but some regions are still not able to get the redirects immediately, but eventually we know that after maybe few seconds later or a minute later, depending upon how soon the convergence happens, the state becomes consistent, they should be able to get the redirect. What do you think will matter more? So there are basically two kind of problems I'm asking, and this is an important question. So the question that I'm asking is, and this will help you understand the consistency in a deeper way. So the first scenario is that some you have shared your a short URL, and now there are two people from two regions are trying to access it. One which the region which is closer to you, where the updates have already synced in the database, and they your service is able to redirect them. And then the second set of users who are for them, the let's say the data center updates have not yet synced in, and they are not able to get the redirect back to the long URL. This is first scenario. In this scenario, the users are still able to see the use the service. Like both the set of users are still able to use the service. The first set of users are able to get redirected, and the second set of users are getting the error that this is not a valid URL, or no mapping exists. Let's say something like that in that moment. uh, so this is first scenario. In this scenario, there is a high availability, so our service is highly available. And consider the second scenario. uh, okay, yeah, you can write. Consider a second scenario. So the second scenario that we have over here is, uh, until the updates have fully synced with all the nodes, let's say with all the replicas, until then nobody will be able to use your service. That's basically the extreme end of the scenario one. So until the updates have fully synced, so it's a highly consistent 100% consistency that we have. So it means that until the updates have fully synced to all the regions, to all the replicas, nobody will be able to use the service, which basically is a banking system or a financial transaction example. It kind of maps it to that sort of problems. So what do you think would be uh, more acceptable in this case? Hmm. Yeah. Yes, perfect. So this is the I hope this clarifies the consistency versus availability in this scenario. Okay. Partitioning, we don't have to talk about that, because that is always given in a distributed scenario. I mean, partitioning always we assume, so in the cap theorem, so we the uh, it's always consistency versus availability what we are choosing, because partitioning is already given. So any distributed system should be able to handle the network partitioning. Out of all the three aspects, we can only choose two aspects. So it all boils down to consistency versus availability what we are choosing. So our system, we decided, is going to be a highly available system, and we are going to trade off bit of consistency in favor of availability. So that's a good point that we discussed. Now let's go. I think we might also be able to discuss one additional point, that how many maximum number of URLs we can support, which, let's say, you already mentioned 1 billion, and how many daily active users are there. But I don't think that it adds a lot of value to the conversation, because just theoretical numbers. But for the sake of completeness, we can add, let's say there are around maybe a billion shortened URLs, and then maybe 100 million or 10 million daily active users that we have. But anyways, that's like not a so we can now go to the next part after the, so we have covered the requirements. Now let's go to the next part. Yes. Yeah. Yeah, go ahead. No issues. Right. Yeah. Hmm. Yeah. 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 We can put a maybe like an absolute time, that expiry, whatever it is. So it's completely open. Yeah. It's not, it's an optional entity. So even if user does not provide, the API is not gonna fail. So it's optional. Okay. Mm-hmm. Okay. No. Mhm. Yeah. Yeah. Hmm. Mm-hmm. 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 Right. Uh, yeah, that's a good point. But be thoughtful about the part that if you introduce deletion, you need to store the user ID, like who is the owner of that short URL, because otherwise, in the initially when we started designing, like you mentioned that user ID we're not gonna store. So just be like thoughtful about those points. Maybe you can just address it that if we want to support deletion, we need to store the author ID or the user ID for that URL, and we need to authenticate while we need to have an authentication. So here we have not added any authentication layer, right? The user ID, nobody is actually logging into our service. So it's like a non-authenticated APIs that we have, all both the post and the get. But if we were to support, let's say the customized ones, where people can delete it or maybe update it, let's update the mapping or provide a custom URL as well to the short to the long URL, like custom alias, then in that case we should have some way of authenticating them, right? Like if they are the actual owners of it or not. So in that case we need to add some authentication APIs as well, which we don't have to like go through each we don't have to go through the authentication APIs, but we can just talk about it so that interviewer knows that you understand the consequences and what comes along with that, right? So but I like the point that you mentioned about the get part, that you explained 301 and 302 and what are the pros and cons for both. So I like that part. Yeah, we can go ahead. Yeah, that's. Mm-hmm. Yeah. uh if you want you can draw as well. So there's a format, like uh, there's a format over there, insert, maybe insert and the diagram, uh, or if you want you can use the Excalibur draw, that is like better. Maybe you can share your screen and paste the image here. I mean, whatever you prefer. Maybe you can use the doc to write itself and later on draw the finished diagram, so we can first go through the description, maybe whichever you whichever you feel prefer. Yes.
Did insert drawing, so let's do it like that. Okay, so Um, I'm just gonna start with the basics that we need. We
Right.
assume, okay, okay. So we assume we have our clients. These are, um, this is the HTML that we serve. We own this client experience, and then we have our server. So I'll put the server over here,
Yeah.
and just kind of like this. And anyways, so we have our server and we have our client. We have our two. Bear with me just as I keep figuring this out here. So we
No.
have our client. Yeah, we support our two interactions through a post and a get.
Yeah.
At minimum, that's all we need. So let's talk about our durability. We're not storing these. We talked about using a NoSQL database. We can't just store the URLs in memory. So we
Mm-hmm.
need to add in a database system as well, which I will put with this.
Sure.
We said a NoSQL database. Um, and we're also not talking about doing analytics in our V1. And so there's um, again, just to go back to what we have, get, post. In both cases, we're going to do a write or a read to the database. I can kind of go, uh, this seems to work pretty good. So the next thing is we start to go, I'm going to open another tab so I can look at my requirements again. So I'm going down in another tab, our functional requirements. We have our limitations of URL. We can do that with the database. Our types, our duration, everything's good. I'm going to NFRs to see if I need to modify this high level design or where to start. Um, we have our latency target. So we want 100 milliseconds for readers. So let me go back to this system. Um, Immediately, what I'm seeing is readers are going to be coming 20 times more than writers to our system.
Mm-hmm.
And so, what we need to do is probably start to look at ways that we can optimize our reading experience. We have a NoSQL database, and um, we want to see probably um, this might get a little complicated, but number one, we probably, with 10 million active users, we're probably not going to be able to handle that load with one server. Assuming that our system, assuming we have URLs, each, trying to state this very clearly, we have to assume there's 10 million URLs, at least 10 million each day where users are going to come and need to come to our server. In other words, what I'm getting at is that the redirect hasn't been cached on their system. So we need to make this server replicated, and so that users are connecting to not just one server but multiple servers. The next thing that I need to talk about is when we replicate our server, we need to make sure that clients are distributed equally across these servers. And really, the approach then becomes to add the load balancer. Doing this will allow us to kind of keep track of in AWS, we do this with, an application load balancer and auto scaling. And we have metrics here. We can scale this up and then we can use our metrics to determine which server is underutilized and fan it out that way. But we'll just say a load balancer here. And we don't need to have anything like sticky sessions. or intelligent routing besides our load here. So potentially this could be a network load balancer, which would even allow us to create um, better latency features.
Right.
So right now I'm focused really on the reads. And if we didn't use a NoSQL database, I'd probably start talking about having a read replica,
Hmm.
because we still have the issue of clients are coming to our system and they're getting distributed evenly across the servers. We can handle the load because we can scale the servers out. But I guess the bottleneck becomes reads to the database. If we assume that there's 10 million unique URLs that need to get looked up each day, we're going to have issues there. There's probably going to be a situation where we have a celebrity and we can assume that the like whatever that celebrity posts, their tiny URLs are going to be accessed more than are going to be probably the bulk of our access from our users. So again, you used Elon Musk. Um, I would assume, we could have, let's just say, if people like Elon Musk and celebrities, that could be up to, I'm just saying, 50% of our read volume. So what we could do is introduce some type of caching between our database and our servers that basically said, well, this would be tough, but um, we wouldn't know exactly who the client is given our API. We wouldn't know this is Elon's URL, but we could keep some type of tracking um, counter somewhere to say, all right, this URL is being accessed a lot, or this subset of URLs are being accessed a lot. Like I guess like an LRU cache or something, and we just make a small Redis cache with like the highest volume of URLs each day. We wouldn't want to cache our entire subset of URLs, because that would I don't know if our caching system would support it, but we can at least try to do some type of caching solution so that we don't have to hit the database each time. So I'm thinking we could put a Redis caching system in between here for quick lookups before we go to the database. And that will take load off our database. So when we have that scale, that high read traffic, we're able to see, oh, do we already have that URL in the cache? Let's return that. Otherwise, let's scan our database indexes. So I'm going to kind of stop right there and I need to drink some water, but I'll let you kind of chime in on where I'm at right now.
This is good. I was actually looking for this. So it's really good that you first acknowledge the problem. The problem is that we need to cache some part of the request, so that for every request it doesn't have to go to the database, because that would mean a lot of load on our database, right? And the Redis part, you can add one more thing. So just a general concept to you. So for any social media kind of applications like Twitter, Instagram, generally it's a rule that 80 20% of the URLs, or 20% of the of the Instagram post, or 20% of the Instagram hashtags, or 20% of anything, they are accessed 80% of the times. So this rule is generally 20s to 80 rule. So 20% of the items are getting accessed 80% of the times. So we just need to cache, let's say, the 20% part of it. We don't have to cache everything. So we can just cache one fifth. And the caching policy can be LRU based. And the caching manager or the caching engine can take care of updating, let's say, if the new URL needs to be cached and someone and previous URLs needs to be evicted, so that caching engine can take care of it. um, so yeah, I think that sounds good to me. What we haven't covered in this yet is about the actual like the overall flow you have, I think, covered. But and one more thing that we can add is this cache, either we can add in between server and database, which is good. The second way, since this is a static content, this is not going to change a lot. This is not going to change because once the mapping is created, we are not providing any uh, update capabilities. So we might also be able to use something like CDN, which is like
Hmm.
close to the users, right? Close to the client. So we might be able to store this mapping, like the LRU based policies or the most frequently accessed URLs over CDNs. So that can be one more thing. But anyways, it's not like
Yeah.
just telling it for the sake of completeness, not like the crucial part. But yeah, but caching I'm good with. And what we need to cover here is we haven't discussed about. So one thing is we can discuss about the end-to-end flow, like for both the flows how it looks like. And second thing is we haven't yet covered about how does the actual generation of short URLs from the long URLs look like, and how do we avoid the problem of uh, collisions, like two long
Hmm.
URLs should never have the same short URLs. So that is, I think, one thing we also
Sure.
need to talk about. Yeah.
Okay, so we need to talk about our consistent hashing strategy. And when we look at our long form URL, it's 200 ASCII characters. And if we put that through a standard hash, um, this is, see, this is kind of getting low level, and I'll do my best, but this makes me realize this is a thing I should look into. Um, so I want to talk about two URLs, a scenario where two people are caching the same URL. And um, let
Only
me go back up to here. Yeah,
one challenging problem in this case that you will face during the interviews is that how will you make sure that like if a long URL is already stored in the database, there's
yeah.
a short URL mapping to it. How would your system ensure that when the new request comes from a different user, for example, with and he is giving the same long URL, how is your system ensuring that is going to check first of all that the long URL exists already, right? Because that can also be a um, because long URL is not going to be a primary key in the NoSQL DB, right? The short URL is the primary key. So how do you make sure that um, in some cases interviewers are fine generating the different let's say even if there are two mappings for the same long URL, there are two different mappings, like sometimes they are fine with that. But let's say there's a constraint that one long URL can have only one short URL mapping. And then second is how do we parallelize or scale the system, so in the sense that if thousands of people are generating, this is for the right part. So if let's say thousands of people are generating the long generating this mapping, a long URL to short URL mapping, how is our service going to scale? So
Hmm.
like
Yeah,
it should not be a global atomic counter. So even if we are using a counter based approach, which basically goes into the specifics of the low level design,
yeah.
little bit, like not too much but little bit into the LLD part, like how do we ensure that it's a parallel, or two people can independently generate the uh, this mapping. So there should not be there should not be a race condition or synchronize. We should not need to synchronize their actions. If we had to synchronize their actions, it would be a blocker in the performance.
Okay. Um, that is going to be homework for me. I'll look into that.
Yeah, maybe we
But
can discuss it in our next session. So these things
yeah,
we can have a follow-up session on this, where we can get to the remaining aspects, and then if time permits we can discuss about the analytics and the optional requirements that we took. But so far, like, this is good. I'm glad you were able to, like, uh, cruise through most of the important stuff, talk about the problems, talk about the you were able to deep dive into plenty of things. So far it's good.
okay, great. Yeah, and I think we're at time. So I'll follow up and I'll send you the PayPal. And we'll go on. I'll text you, but yeah, I'd like to do a little negotiating on the rate.